always say stuff.
All right. I need you to sit down, and I need you to get ready, because we're learning. With or without you. All right, here we go. Pythagorean theorem. We've already proved it works. How did we prove Pythagorean
A squared
theorem?
plus B squared equals C squared.
Okay, that is what the Pythagorean theorem is.
Yeah.
How did we prove that that works? What did we use?
By using the triangle.
Yes, we did. We used similar triangles in the last unit to prove that the Pythagorean theorem holds true. Now, we can use the Pythagorean theorem for what kind of triangles?
Right triangle.
Okay, so in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, so you have already learned how to do this. Now this year we added to that being able to simplify radicals. So I'd like you to take these three problems, and I would like you to find the missing side, but this time, instead of last year you gave a decimal, this time I want you to give it in simplest radical form, please. Take about a minute.
Yes, ma'am.
I have a question. May I run to the restroom like super quick? Like super quick.
Can we use calculator?
No calculator.
Do what? Oh.
Simplest radical form. That means simplify the radical.
No, but like I can see you from like right over here.
Yeah, that's what
Yeah. No, but like
Yeah, but I see.
like it's reflecting off my glasses, so I don't have to look at it. It's just 28. You don't have to know. If I sit like this, I can see my eyes. So I use myself.
Oh, I did that.
I just look at my eyes.
Yeah, the biggest.
What?
Yeah.
I probably won't, but that's okay. I'll just try to. Taking a photograph really quickly.
Okay guys, let's take a look at these. In the first one, leg squared plus leg squared. 6 squared plus 4 squared equals c squared. So 36 plus 16 equals c squared. 52 equals c squared. Now normally when you take the square root, you get plus or minus, but in this case I only get the positive because c is a length, isn't it? Is there any way to have a negative length? No. So we're just looking at the positive square root of 52. Well, we know that 52 breaks down into 4 times 13. And the square root of 4 is 2. So simplified, this would be 4 roots of 13. That's my simplified. Yes, thank you. 2 roots of 13.
I said the same thing.
Okay. On the second one, we have 8 squared plus 8 squared equals c squared. So 64 plus 64 is 128. But I'm not going to write it that way. I'm going to write it as 2 64s. Why did I write it like that?
Because it's the same thing.
Because now I can see it's 8 roots of 2. Simple. Whoops, that was right. 8 roots of 2 equals c. Okay, on the final one, we can call this side A, we can call it B, you can call it X, you can really call it anything, but we know that 2 squared plus, I'll call it B squared, equals 7 squared. So this is 4 plus B squared equals 49. So b squared equals 45. And then I take the square root of both sides, and 45 breaks up into 9 times 5. So b is 3 roots of 5. And there's our missing side. Any questions about that?
Okay, I didn't get this before, but now I'm actually understanding.
Oh, cool. Very cool. Well, we're actually going to be using some of this within the problems that we do over the next couple of days.
Okay.
Okay? All right, so today we're going to learn, in addition to the Pythagorean theorem, we're going to work with 2 other special types of right triangles. The first one that we're going to look at is called a 45-45-90, which is the same as an isosceles right triangle. And the second triangle that we're going to look at is a 30-60-90. All right, we're going to derive this pattern that works for all 45-45-90 right triangles, and we're going to start with a square. So I'm going to mark this like it's a square. So now I've turned it into a rhombus. I'll throw a right angle in there. So now I'm a square. Do we know what any of the lengths of the sides of this square?
No.
No, we know
So
they're all
what
the same.
we're gonna use a variable x.
Oh, I like that one.
Good. My favorite. Okay, now to create a 45-45-90 right triangle, all I have to do is take this square and put in the diagonal.
See?
I actually created 2 45-45-90s. Mine are close enough. But we're just going to look at one of them. And we know these 2 triangles are congruent. How could they be congruent? Side, side, side. Yeah. Reflexive property right there. We know they're congruent. But we don't know what the length of this hypotenuse is on that 45-45-90. So let's go back to what we know must be true on any right triangle. A squared plus b squared equals c squared. The sum of the squares of the legs is equal to the square of the hypotenuse. So leg squared would be x squared plus leg squared, x squared, equals hypotenuse squared. I don't know what the hypotenuse is, so we'll call it c squared. So here I have 1x squared, and I add another x squared to it. So how many x squares do I have now? 2x squares equal to a c squared. What do we do, guys?
Can't do really anything.
How do we solve for c? What undoes a square? Square root. So we'll take the square root of both sides. Now, the square root of 2, there's no perfect square. That doesn't simplify, does it? But the square root of x squared. What's the square root of x squared?
X.
X. So it leaves me with x times the square root of 2. Well, this is really, really cool. Because anytime we have a 45-45-90, and I could mark it with the congruent sides or the congruent angles, or I could just show you that one of them is 45. Anytime we have a 45-45-90 right triangle, whatever the legs are, to get the hypotenuse, you just have to multiply by the square root of 2. Whatever the length of the legs are, to get the hypotenuse, you multiply by the square root of 2. Is this a 45-45-90?
Yes.
Yeah, because an isosceles right triangle. What were the legs?
8.
8. What was the hypotenuse? 8 times the square root of 2. So whenever we have a 45-45-90, and I can mark it with the angles or the sides, this one's marked with the angles. So if this leg is 8, then this leg must be 8, and the hypotenuse is 8 times the square root of 2. Okay? Yeah.
So that means it's
All right, and we can go the other way. On the next one, I showed you the hypotenuse is 5 roots of 2, so the legs would be 5. On this one, the hypotenuse is 10 roots of 2, so what would the legs be? 10. Okay, on this one of the legs is the square root of 2, which is a little tricky because that makes you think hypotenuse, but it's not. It's actually a leg. So what would the other leg be? The other leg would be square root of 2. Now to get the hypotenuse, we take that square root of 2, and it gets multiplied by square root of 2. So it's 2. It's 2. Okay, so this is 3 roots of 2. So what would, oh, do you also see I marked this one differently? You can mark it either way, or I could just put 45 degrees in the corner. This is 3 roots of 2, so this leg is also 3 roots of 2. What would the hypotenuse be? 6. So it's 3 roots of 2 times the square root of 2, which is 3 times 2, or 6.
How is it 3 square root of 2 times the square root of 2? Would it be 3 square root of 2 times the square root of 2?
Okay, every time to get the hypotenuse, what do we multiply the leg by?
Oh,
Just the square root of 2.
yeah.
Okay. All right, now this time we have a hypotenuse, and the hypotenuse doesn't have a radical 2 at the end of it. So we can't just drop the radical 2 and keep the number. So what do we have to do here?
You divide by 2.
You divide by the square root of 2. So we can't leave a radical in the denominator, so we have to rationalize, which gives me 8 roots of 2 over 2, which is 4 roots of 2. Now, some of you may be like me, and you're kind of backwards thinkers. When everybody else was learning how to subtract, you just added backwards. When everybody else was learning how to divide, you were thinking, ooh, what do I have to multiply to get this? So I am a backwards thinker. So what I did was, okay, what do I have to multiply by the square root of 2 to get 8?
That's what I was thinking.
Well, I doubled something, because anytime I do square root of 2 times square root of 2, it doubles something, right? So what did I double here? Well, I had to double 4 to get 8. So 4 roots of 2 times root 2 gives me 8. And that's the way my little brain thinks about it. Now, I don't care which way your brain thinks about it. Just get it right. Okay? All right, oops, there's one at the bottom of the page, isn't there? Okay, and what is the hypotenuse of this one? 20. So 20 would be 10 roots of 2.
That's what I got too. Cool. I'm happy for you.
Okay, so 45, 45, 90 is nice and easy, isn't it? 30, 60, 90 is nice and easy too. So let's go through that so that it makes sense. Okay, so with a 45, 45, 90, we started with a square. To get a 30, 60, 90, we're going to start with an equilateral triangle. Because what are all the angles in a equilateral triangle?
Equal.
They're 60, right? They're all equal. They're all equal, and they're all 60 degrees. So we know this is 60 degrees right here, and they're all the same. Okay, so to create a 30, 60, 90, I'm going to drop down a perpendicular right here. I'm going to drop down a perpendicular. Because now I've created, if this is 90, what does it leave right here?
30.
30. I didn't just drop down a perpendicular, I actually dropped down a perpendicular bisector. So if I had originally called all these sides x, what would this little side be now? Half x. Good. So now if you notice, what I did was I created, whoops, this one. Right here, I made a 30, 60, 90 right triangle. Okay, so I'm going to pull that part out and put it over here and make it bigger. Okay, so we said this is 60, and we know this has to be 30, and this was x, and this is x over 2. So I had to find this side. What do I do, guys? Okay, so you're thinking there's going to be some kind of shortcut. Do we know the shortcut yet? No. So what did we use to find the last shortcut? We used Pythagorean theorem. So we're going to do leg squared, so x over 2 squared, plus leg squared, don't know what it is, we'll call it b, equals hypotenuse squared.
Wait, what's B?
The one we're looking for.
Okay.
We'll call it b for right now. Okay, so when I square all this, the x gets squared, the 2 gets squared, so that leaves me x squared over 4. Isn't that like 1/4 x squared? X squared over 4? Yeah. Okay, so b plus b squared equals x squared. So we're going to solve for b squared. So what do we have to do?
Divide, the square root.
Not yet.
Subtract.
Got to get rid of this. So we're going to
Multiply
subtract
four.
that. We're going to subtract this from both sides.
Wait, why
So
did you keep the square?
Go on.
I haven't taken the square root yet,
Oh.
so I have to keep the square.
Oh,
Okay, so I'm subtracting x squared over 4 from both sides. Are we good? So now that leaves me b squared is equal to, well, what is 1 minus a fourth? 3/4. So that leaves me 3/4 of x squared. Are we good with that? 1 minus a fourth, 3/4. Now I'm left with this b squared over here. So what do I do?
Take the square root.
Take the square root. And once again, we know it's a length, so we don't have the plus or minus. Okay, we don't know the square root of 3. It's got to stay. We do know the square root of 4, though. What is that?
2.
2. And we do know the square root of x squared. What is the square root of x squared? X. So this length right here is just square root of 3 over 2 times x. Now, I've discovered that a lot of my students aren't real fond of fractions.
Yes.
And because I can write this as a squared times b squared equals c squared, you see how I could do that? Would it be fair to go through and take this whole equation and multiply everything by 2?
Yes.
If I did, multiplied everything by 2. So I'm going to multiply this by 2. I'm going to multiply this by 2. And I'm going to multiply this by 2. So what happens to that 2? Goes away. What happens to this 2? It goes away. So now I don't have fractions. Some of you may be okay with fractions. Some of you might not like them. So once I multiply through, I make my fractions go away. So this is 2x. This is x. This is x root 3. And this is what we need to know. Whatever the shorter leg is, the shorter leg is always across from the 30-degree angle. We call that the short leg. Whatever this leg is, do you see we just double it to get the hypotenuse? And then whatever the short leg is, we just multiply by the square root of 3 to get the longer leg. So the short leg is our big deal. This is where we always want to start, is with the short leg. Okay, so let's take a look at this problem. We're going to start here. We're going to call that example 1. Across from the 30-degree angle is our short leg. It's 8. So to get the long leg, we just take that and multiply it by the square root of 3. And to get the hypotenuse, we just take that short leg and double it. I'm going to erase this just so we don't get confused here. Does that make sense? Okay, now the short leg is always the best place to start. But if we don't start with the short leg, that's the first place we're going. So on example 2 here, I'll do this one next. They gave us the hypotenuse. Well, the hypotenuse is just twice the short leg. So what's the short leg? 14. And then the long leg would just be times the square root of 3. Does that make sense? Okay, let's look at the third type. The third type is where they actually give us the long leg. So what do we do to go back to find the short leg? You divide by the square root of 3, which just gives us 9, and then double it. 18 gives us the hypotenuse. Okay? Number 4. The short leg is 1. The hypotenuse would be 2. And the long leg would be this 1 times the square root of 3, which is just square root of 3. Number 5. The hypotenuse is 6. So where do I go first? What does that tell me?
Short leg's 3.
The short leg is 3. And then the long leg would be 3 roots of 3. Very good. Okay, number 6. Which one did they give us? The long leg. So first place we always want to go is the short leg. It's just 7 over 2, 7 halves. And when we take 7 halves and double it, what happens to those 2's? They cancel, and what do we get? 7. Okay, let's take a look at this one. This time they gave us the hypotenuse, so what's the short leg? 2. And what would the long leg be? 2 roots of 3. Number 8. The short leg is what they gave us, 9 halves. What's the hypotenuse? 9. And what's the long leg? 9 roots of 3 over 2. Okay. Number 9. This time they gave us a short leg that actually had the square root of 3 in it. So to get the hypotenuse, we just double it. So when we double 2 roots of 3, we get 4 roots of 3. But to get the long leg, we have to multiply this times the square root of 3.
6.
Very good. 2 times 3 is 6. Is our long leg. Okay. Last one. This time they gave us the long leg. So you have to divide by the square root of 3. So what'd you get, Matt?
4 roots of 3.
Good. 4 roots of 3. So this is 8 roots of 3. So when you take 12 and divide by the square root of 3, we have to rationalize. Square root of 3 over square root of 3, which is 12 roots of 3 over 3, which is 4 roots of 3. Any questions? All right, so these kind of went quickly, didn't they? All right, your homework is out of your workbook. Now, the page 196 is all review of Pythagorean theorem, but that's still important. So, 200 and 201 is where we use our special rights. Now, with Pythagorean theorem, you can use your calculator. With special rights, unless it tells you to give the decimal approximation, I would like you to do it with no calculator, please. Okay, so your homework is written on the big screen right now. You don't even have to look at the board. It's hard to see on the board. Your homework is written on the big screen.